Today I'm gonna talk about the derivative of composite function, chain rule, trig function, and exponential function. Now let's take a look. The derivative of composite exponential function a to the power fx equals ln a times a to the power fx times derivative of fx. I also put the standard derivative of exponential function a to the power x prime equals ln a times a to the power x. Let's compare these two. We can find the derivative of composite exponential function has extra term, that is the derivative of fx. Okay, and the third formula is constant multiple rule. The derivative of k is constant times a function fx equals k times the derivative of fx. And here I also list the derivatives for all trig functions. Now let's take a look at the first example. For the first example, we can see that fx equals 2 sine x. Okay, so we can follow the formula. Here the a is e, so we can have ln e and e to the power fx. Fx is 2 sine x, and then times the derivative of fx, and we know the ln e is 1, so we can simplify it. E to the power 2 times sine x. So what is derivative of 2 times sine x? And we can see that is constant multiple rule, right? Here's a constant, so that means we can pull the constant 2 out of the derivative. So we have 2, and we're gonna do the derivative for the function. Okay, now derivative of function sine x equals cosine x. So 2 cosine x times e to the power 2 sine x. Now let's take a look at the second one. The second one, we can tell the fx equals tangent x plus 3 cosecant x. Now let's follow the formula. Ln a, here a is 2, ln 2 times 2 to the power fx, that is tangent x plus 3 cosecant x, and we're gonna do the derivative of fx. Okay, and let's focus on the last term. Here the derivative of the sum of two functions, that means we can do the derivative for each term. So we can simplify it. Copy the first two terms. Okay, and then we're gonna do the derivative for each function. 3 cosecant x. Now let's take a look. It's very easy to figure out the derivative of tangent x, that is secant x squared, and for the second one we're gonna apply the constant multiple rule, right? We have 3, so we can pull the 3 out of derivative. Okay, so now we can simplify it. Then 2 times fx tangent x plus 3 cosecant x, and tangent x prime gonna be secant x squared, and for this term will be 3, and cosecant x is derivative of cosecant x gonna be negative cosecant x times cotangent x. So basically here should be a negative 3, so we can get negative 3 times cosecant x times cotangent x. Okay, now let's take a look at the last example. The last example, we can tell what is fx. This fx is 3 secant minus 7 cotangent x. Okay, now let's follow the formula. We have ln phi to the power fx, that is 3 secant x minus 7 cotangent x, and we do the derivative of fx minus 7 cotangent x. Okay, again we can see here's the derivative of the difference of two functions. So that means we're gonna do the derivative for each term. So we're gonna copy the first two terms, and for the last term we have 3 secant x prime minus 7 cotangent x prime, and we're gonna focus on these two terms. The derivative of 3 times secant x, we're gonna apply the constant multiple rule. Zeta will be 3 times the derivative of secant x, and this term will boil down to 7 times cotangent x prime. Okay, now we can simplify. Then ln phi to the power 3 secant x minus 7 cotangent x, and for this term we need the derivative of secant x. Derivative of secant x gonna be secant x times tangent x, so have 3 times secant x times tangent x, and what is derivative of cotangent x should be a negative cosecant x squared, negative positive, so we have 7 cosecant x squared. Okay, so that's the answer.